So I wanted to make a brief video to help you get started on problem number 4 of today's problem set, which is this question with the boat. So here's the setup. A boat moves 5 miles per hour faster with the water in the same direction as the current. It moves faster with the current than it does against the current, in particular 5 miles per hour faster with the current. Now, because it moves faster with the current, it can travel a further distance with the current. 50 miles with the water in the same time, it can travel 40 miles against the water. And so ultimately what we're going to try and find out is how fast precisely is it traveling with the current, and how fast is it traveling against the current. So once again, if the question is broken down into steps like this, I beg you to try and limit yourself to taking these problems one step at a time. I really have tried to encourage folks by giving you such a small amount of space here. Really take this slow and do the bare minimum to make each part happy. So it says in part A, for example, let R represent the boat's rate against the water. Write an expression containing this letter R, representing the boat's rate with the water. Okay, so if the boat's rate against the water versus the boat's rate with the water, if with the water is 5 miles per hour faster, then the rate with the water could be found by taking the rate against the water and increasing that by 5 units. So here's the rate against the water, and here's the rate with the water, R plus 5. I'm going to call it there because that's all that part A is looking for. So then it says, okay, now I'm still going to let R represent the boat's rate against the water, rate against. Write an algebraic expression containing R that represents the boat's time to travel 40 miles against the water. And here's a hint. Distance equals rate times time. This is sometimes called DIRT for short. Distance equals rate times time. So translating that, I would have 40 equals the rate R against the water times the time it would take. Now, if I wanted to write an expression that represents the time, I would rewrite this so that time was all by itself. Time is what? Now, to isolate time, I need to get rid of R. And to get rid of a multiplied R, I have to divide by R. The time required is 40, the distance, divided by R. And this expression, 40 over R, represents the time against the water. So here's what we are doing for the next couple of parts. Part C, write an expression that represents the time to travel 15 miles with the water. And then once you have those two times, you can write an equation that represents that those two times are the same. And if they're the same, then they're equal. And you can solve that equation for R.